Cool guys, so we're on question 7 here of the grade 12 June 2025 math paper 2 paper. So question 7 is the beginning of Euclidean geometry. It builds up from question 7 being just identifying the angle, giving a reason, 1 mark for the angle, 1 mark for the reason, like then it moves to similarity and then it moves to riders and then we are done. This is the same format for June, prelims and finals. So question 7.1, P, Q, R, S, T lie on the circle with center O. So we have the origin, which means we have radii, and we have a diameter, for example. So these are things to keep in mind. Whenever we have a center, we have to look for radii and diameters. So PR is perpendicular to OQ. Okay, so we have the 90 degrees here, and these two lines intersect at F. Great, so we have to keep this in mind. If we have a 90 here, we also have a reason that we can work with. So POT is a straight line, so that means that is our diameter, and then P1 equals 42 degrees, which they gave us on the diagram. So 7.1.1, determine giving reasons the sizes of each of the following angles. So R1, what is very important here is that POT is a straight line and that O is the center, which means PT is a diameter and this shape here is a right angled triangle because we have angle in a semicircle. R1 equals 90 degrees. We got 1 mark just for saying that. If we didn't know the reason, we could still write this and we'd get 1 mark. And then all we write is angle in semicircle. So now that we have that, these questions lead on. This was A and now we're on B. They want the angle of S. So S is over here. So we need to see, are we going to work from this 90 degrees here to get S, or are we going to work from this P1 where they give us the angle 42 over here? So getting from 90 into there is a bit tricky, which means going from the 42 degrees, jumping directly opposite, because then we are in PRST, which means this angle, S over here, is the opposite angle of P1. And a reminder that if all 4 points are touching the sides of the circle, it means we're dealing with up angles of a cyclic quad. So that means we don't have to write all our working out, but we can just do it just so we can understand. P1 plus RST over here equals 180 degrees. We don't get a mark for showing our working. This is up angles cyclic quad. And then at this stage, we know P1 is 42 degrees plus RST is there. That equals 180. We take the 42 over and we are left with RST, and RST has a value of 138 degrees. So P1 plus S add up to 180 degrees because up angles cyclic quad. And now we're on C, a follow-on question asking us for the angle of PQR. So PQR, this whole angle here, Q1 and Q2 together. So there's a couple ways that we can do this. There are multiple different shapes here. We have triangles, we have various cyclic quadrilaterals, and then the question we ask ourselves is, can we use this 138 degrees to calculate Q1 and Q2? I imagine we can, but it's a bit tricky at this stage. The easiest way might be to work with this 90 degrees here, this R1, because if we work back in triangle PRT, we can then calculate T2 here. Once we have T2 here, we can then work in this cyclic quadrilateral QRT. And then once again, T2 plus Q1 and 2 combined add up to 180 degrees because opposite angles of a cyclic quadrilateral. So we're working in 2 different shapes. We have the triangle, which we're going to get T2, and then we're going to work in this other quadrilateral to get Q1 and Q2. So it's 3 marks, which means we get 2 marks for a statement and 1 mark for a reason. Okay, so T2 equals 180 degrees minus 90 minus 42. So we don't have to show our working. We can just do it on a calculator. And this equals 48 degrees. Great. So this is interior angles of a triangle. And now, like we spoke about, T2 plus Q1 and Q2 equals 180 degrees because of up angles cyclic quad, which means we just worked out T2. It is 48 degrees. So we have 48 degrees plus this guy equals 180 degrees. Take the 48 over and PQR, like they were asking for here, equals 132 degrees. Okay, great. So 7.1.2, it is a 3-mark question. It says if PR, so PR over there is 7 centimeters and QR over here is 4 centimeters. I'll mark that down. So we have 4 centimeters. Determine the length of QF. Okay, so QF is over here. That is a question mark. That is what we want, this length over here. So once again, this is 3 marks. What we're dealing with at this stage are the lengths of a triangle, QFR, because once we are in QFR, we can then use Pythag to calculate QF. So they've given us QR, that is 4 centimeters here, and then FR we can calculate from the fact that we know PR equals 7 centimeters. So PR equals 7 centimeters. This is given. We don't get any marks for that. But then PF equals RF equals 3.5 centimeters, because line from center perp chord. So we see that this line from the center, this radius, is perpendicular to this chord here, PR. And this is one of our reasons, which means that this length equals that length. And therefore, if this whole thing was 7, it means PF equals 3.5 and RF equals 3.5 centimeters as well. So now that we know that FR is 3.5, we also need to get a 90 degrees in triangle QFR. And that is quite easy for us, considering they've already given us this 90 degrees here, which means QFR, the angle for it, equals 90 degrees as well, because we are doing angles on a straight line. So we have angles on straight line. And now we're in triangle QFR. We have the 90 degrees. We have the lengths of 2 sides, which means we can just go ahead and do Pythag in order to get QF here. So QF squared equals our 4 centimeters squared minus our other side, FR, our 3.5 squared. Okay, so we have Pythag over there. Cool. And then we can just go ahead and solve for this in our calculator, squaring these guys, subtracting them, taking the square root. So we have 16 minus 12.25. That equals 3.75. And then we just need to take the square root of that. And we have QF equaling 1.94 centimeters. And that is our final answer. Great. And then question 7.2, in the diagram below, B, D, and C lie on the circle with center O over here. AB over there and AD are tangents to the circle at B and D respectively. And then they have BAD is 59 degrees that they're marked on here. So we're working with tangents. We do have a center of a circle, so we can keep that in mind. So determine, giving reasons, the sizes of each of the following angles. We are calculating B1 over there. So 4 marks, B1 over there, and the only angle they've given us to start with is angle A over here. So one thing to keep in mind, whenever we have a tangent, we're looking for tans from the same point. That is very important, which means the fact that B is over here and D is over there, it means that AD is the same length as AB. That'll be great for us. One other thing to keep in mind is tan chord theorem, should we need to get into the circle. And then if there was exterior angle of a cyclic quad, we'd look for that as well. So that means we're at a good starting point. The fact that we want B1 is great, considering we know the angle A and we know AB is AD. We do have to write that with a reason, so we're going to start there. AB equals AD, tans from same point. So because of that, we can then do interior angles of a triangle, saying A plus B1 plus D1 equals 180 degrees. Interior angles of a triangle. So then A we have, that is 59, and B1 and D1, they are both the same angle. B1 equals D1 because angles op equal sides, okay, which means that B1 equals D1. So then we had A is 59 degrees, B1 plus D1, we can just call them X plus X, and that equals 180 degrees. So then 180 minus 59 is 121 degrees, and X plus X equals 2X, and then we can go ahead, divide this by 2, divide that by 2, and X equals 60.5 degrees. And reminded that X was B1 over here, so therefore B1 equals X equals 60.5 degrees. And then at this stage, 7.2.2, they're asking for the size of angle O1 over there. So this is a 4-mark question, and this is the last question in the section. So we just calculated angle B1 here. These are all follow-on questions for a reason. We worked with A, got B1 over here, and now we need to get into the circle. So the easiest way to do that, like we mentioned, we used tans from same point. There's also tan perp rad, which we haven't spoken about. about, which means this guy is 90 over there. And then the other thing to keep in mind is tan chord theorem. Whenever we have a tangent and we see some sort of triangle like DBC, for example, where all 3 points are on the circumference, it means we can use tan chord theorem. And the way that we do tan chord theorem is we jump into this whole triangle and then we jump across to the further side. The reason this works regardless of whether you're taking it from B1 or D1 is that when you jump in and you go to C, from here you jump in and you go to C as well, which means C over here is 60.5 degrees because of tan chord theorem. Okay, that just earned us 2 marks, 1 mark over there for our angle, 1 mark over there for our reason, and then we're just 1 move away from 01. One thing to keep in mind when we always have an arrow, something that looks like this, for example, is angle at center equals 2 times the angle at circumference. The fact that they both share dB and we can trace from B to O and D to O and also D to C and B to C means we're dealing with angle at center equals 2 times angle at circumference, which means 01 is just 2 times 60.5, which means it is 121 degrees. And the reason, once again, is angle at center equals 2 times angle at circumference. And that is our final answer for 01 over there. Great job, guys. Let me know if there are any questions in the comments below, and then I will see you in the next video.